What's up, friends? Decentralized AI here. I just wanted to drop a video in the meantime. I am running into a personal bug on here, trying to get the node working on the PepeAI testnet via WSL2. But I did come across some more information that was really good that I wanted to share with you guys, since right now we're all trying to figure out which GPU is going to be best to buy, what GPU is going to be best to utilize. We're trying to figure out what, bang for our buck kind of idea is. So I came across this, which GPU is best for deep learning. This is written by Tim Detmers. It was written in January 21st or January 23rd, 2023. Or January 30th. I'm sorry. But it's got a lot of information. This Some of it's going to be really thick, I think is a great way to put it. So what I'm going to try to do is break into this softly on this video, give it a touch over on a lot of the topics, start breaking certain things down a little bit, showing you which GPUs are capable of what. Also, you'll see we'll be able to understand which GPUs and how they're efficient or how it works for you, because every situation is going to be different now. So if you're coming out of mining, you can't use the same kind of infrastructure that you were doing for when you were mining. Instead, you're going to have to invest a little bit. There's going to be a little bit more around it. But today's video is definitely going to be just strictly on GPUs. So the beginning of this is what is important for your GPU. The answer on that one's going to be tensor cores. If you have tensor cores, that means that your GPU can feed information faster, and the faster that it can set up a matrix, the faster it solves it, gives you that little percentage boost above, such as something like an ampere. So that's an important bit. The next thing that's going to be important is going to be your memory bandwidth. So as fast as you can fill up those tensor cores with information is going to be the faster that it can do its job. So these are kind of like a succession of bottlenecks is what I'm going to put it as. So the reason why I bring these up is because we'll go over a little bit more later, but if you had a 20 series card and then you only have a 96K bandwidth, then regardless if you have tensor cores or not, you're only feeding it the 90K kilobits per second versus a 30 series card, which is going to fill it at 128. So that already gives you a 25% different boost into the information that it needs. And that's what it is machine solving. So it's going to be it's not just numbers and it's not solving headers. This is actually going to be taking a deeper use of this and basically creating a matrix of context out of words, kind of like a language would do for a person. It's really interesting the more you get into this. So back to this. Tensor cores, memory bandwidth, and then the last bottleneck on there is going to be your L2 cache, your shared memory, your L1 cache, and your registers. This is like the information that's stuck inside the card, or kind of like it's like memory. The L2 cache and the L1 cache. So the L1 is going to be like a warehouse. This is like your backup warehouse. Your shared memory is one of the ways that it passes the information between the two, and your registers is how it's going to pass into the memory bandwidth to the tensor cores. And the bigger they are, the slower they are. The smaller they are, the faster they are. But the faster they are, the less information they can hold. Whereas the bigger they are, the more information they can hold. So it's like a triangle thing. It's a trilemma that you can only have two out of. So they try to use a balance of all of them to be able to move the information at appropriate speed. So moving on from there, there we go. Here's that example I was talking about. So the Turing RTX 20 series, the 96 KB shared memory bandwidth. Now they only have a 5.5 megabyte L2. Now versus a 128 kilobyte shared memory and a 16 megabyte L2. So that means that this one can move information almost 25% time faster than this one. Especially when you get parallelizing your graphics cards because your, let's say if you put a 2080 on same rig it's got a 3080 on it, the 3080 isn't going to run at the 128 kilobits. It's only going to be able to run at the 96 kilobytes. So if you have that, uh, it's going to limit the rest of your rig down to your lowest card. So you're going to want to make same card rigs if you can. That way you will be maximizing the shared memory of the lowest card against all the parallelized. So let's see here. We'll get into more some of this later. Um, Obviously, the 30 and the 40 series will have a advantage. That's just going to be like every single generation, just like the 50 series is going to have an advantage over the 40 series. The and that's just what it is. But if you have 20 series laying around, you'll be surprised how good some of those cards will actually be for this. This is all the matrix and how the learning works, and I want to get into this, but I want to do it at a later video. This one's mostly about just getting information about specifically GPUs for people in general. So, fan designs and GPU temperature issues. Since you are going to have a bunch of them tightly compact together, learning getting server cases is probably going to be a must for this, just to have the high intensity airflow. The These are 16x uh, extender cables. They're not risers, but they do work. Um, so just be mindful. The other thing that we're going to have to do is keeping an eye on power limiting. It's going to be very important, especially when the AI starts taking off and there's a lot of overhead on it. Then that starts um, the usage of our GPUs will flare with how much voltage is allowed to be used through it. But at the same time, it's also how much is being used on the back end. So a GPU will sit idle. Like I have a 3090 right now that sits at like 24 watts sometimes. And then when it's in use, it jumps up to 130, 240. But 240 is the only one time it actually even went up that high. But it's a possible thing. So we're going to have to start power limiting this probably when it after testnet phase. So I just want to keep that in mind. There is a point where power and efficiency is going to have a sweet spot, such as this is at 125 power. So at 50% power, he lost only 26% um, processing speed. Whereas if he started spending more power, it starts getting a diminished gains on how much you actually are getting back. So it may have been nice that he only lost the 26, but if you actually cranked it up to, three quarters of the power, you're only getting 10% more, so and then from there on it gets harder and harder. But we probably won't even run it this far. This is going to be potential, cause an issue with your connectors. You kind of want to keep things a little bit under so they will always be a safe continuous thing. um, so I have learned that there is two different kinds of bits when it comes to the machine learning. um, it's the 8-bit interface, the 16-bit. The 8-bit isn't really heavily prevalent right now, but it involves a lot of coding. But the 16-bit is the current one that they are using. But at the time of writing of this article, which is about 3 months ago, he said that with 6 months, 8-bit will be mostly everything. And 8-bit seems, but it kind of comes down to how much you want to put into this. I thought I seen something on the testnet saying that it is currently 8-bit. So the it does go over server GPUs here too, but I'm not going to worry about those. Right now, we're focused on decentralized, which means that we want the lower entry barrier. Um, the more the easier it is to enter this, the more people that will, the more decentralized we become. So at the lowest end, you have your 1070 Ti's, 1070s, 3050s, 3060s, 1080s, 3070s, and these are all based off computing ability. So um, this is how they stand as they are, not looking at price. The only one we cannot use here is the 1060 This one has a 6 GB. You need 8 and above on the RAM. Some of these cards do pretty decent, even compete with uh, uh, server grade essentially GPUs, like the 3090 and the 3080 beat out the A6000, whereas the V100 is only a little bit more than the 3090. And here we have the 3080 and the 3090 are extremely close to each other as well. 4070 Ti. Then you start to notice that the 88 Lovelace, I think, is going to have a play into the whole 8-bit, to be honest with you, because it seems like the more all the 40 series cards are up around there. But the cool thing is, part of this article, it does have a another chart on here where it is your relative performance per US dollar. So this is a really good chart too. So looking at this, the V100 is probably going to be the least, and it goes up. Some of these cards actually start beating out other ones. But 4080, 4090, 4070, obviously at the top, most performance. 3080, which I'm surprised beats out the 3090 when it comes down to price. Probably power too, and less overhead. You have a little bit smaller card. It's a good one. So even like the 80 series across, a few of these are seem to be giving the most balance. Each of these household GPUs seem to be doing pretty much standard, 16-bit training, 16-bit interface, and 8-bit interface across the board until you get to that 40 series card. But I do know that on that 40 series card, I believe that they got rid of NVLink, so it's harder to do the parallelization, because then you're going to need Gen 5 PCI slots in your motherboard in order for that to work, I believe. There's going to be a later video for NVLink, probably one of the next few ones, but just to make sure we all understand it, because soon we'll have the test rigs, but we're going to want to build more. It gets a little addicting. So going off some more stuff here, that's all the acknowledgements, all that. There we go. It's got a kind of funny little flow chart here. So organization, yes. Trading and LMMs, yes. Money, then it tells you got these ones. If you're poor, it tells you, sorry, do something else. It's pretty solid. There's better to wait for GPUs, the future of GPUs. In this, it actually says no, you might as well get them now, start now, because the better you'll learn along the way. Every series is going to have something more. Here it talks about PCI 4.0 versus PCIe 5.0, which is what I was just talking about when you have a GPU cluster in an 8x GPU machine, but otherwise it does not yield many benefits. When it comes down to it, you'll probably have, let's see here, it says the benefits may be as little as 1 to 7% better parallelization in a 4 GPU setup. So if you're getting that large, it might be something to look into, but it's not gonna break the bank. Usually you don't need to worry about it too much. Do I need 8x 16x PCI lanes? Same as a PC 4.0 generally. No. It does talk in here where operating GPUs on 4x lanes is fine, especially if you only have 2 GPUs for a 4 GPU setup. I would prefer 8x lanes per GPU, but running them at 4x lanes will probably only decrease performance by around 5 to 10% on parallelization across all 4 GPUs. And what I kind of extrapolated from this is saying that if you're going to have 4 or more GPUs, then you're going to want 8x lanes for each of those. And if you're going to have 8 or more GPUs, then you're going to want 16x exchange between all those, because it needs to exchange that data faster and as fast as it possibly can to earn this much. But any of the bottlenecks that you create in this machine will cost you a little bit of rewards in the end. Let's see here. Do I fit a 390? So how do I cool them? That's definitely gonna come. We're gonna have a video about that. That'll be learning how to power limit, learning how to run the fans. This one's important. Can I use multiple GPUs of different GPU types. Yes, you can, but you cannot parallelize efficiently across GPUs of different types since you will often go at the speed of the slowest GPU. Data and fully shared parallelism. So different GPUs work just fine, but parallelization across those GPUs will be inefficient since the fastest GPU will wait for the slowest GPU to catch up to a synchronization point. So that's what I was talking about earlier, where that 96 kilobytes is going to be the speed that a 30 series card is going to go if it's in the same rig as another 20 series card. So keep that in mind. NVLink, is it useful? Generally, it's not, but it's used kind of like to interconnect between GPUs. It is useful if you have a cluster of like 128 GPUs, which is somebody out there has that. Um, let's see here. The Yeah. So the carbon footprint's an interesting thing. Kind of talks about how when you're not using it, it's not going to be creating anything. So running a blockchain like this is going to be cool because this doesn't really talk about. This is how I'm viewing it. Is that solo mining instead of using power on a consistent basis, this would be the exact same as solo mine, except for your PC only draws power when it's creating and finishing work, and then it would draw back down. So you wouldn't be gambling so much as more or less getting like a server rented out essentially. Um, but yeah, a lot of this stuff. Oh yeah, this is another thing that's really important. Will AMD GPUs or ROCm ever catch up with the NVIDIA GPUs and CUDA? Not in the next 1 to 2 years, this guy says. So it is a three-way problem. It's going to be Tensor cores, their software, and their community. He goes into more definition than that, but that's a pretty clear cut answer right there. The fact that they don't have the Tensor cores, there's no point in keeping up with it. If the software can't communicate with it, there's no point in talking to it. And if the community, I'm not sure exactly what he means. I haven't looked into that, but the keep going down here, and that's basically it. So this will give us like a pretty good idea, like I said, that what to expect, what how a GPU is going to work, what things we're looking for in a GPU. And I'm just going to recap with this real fast. You're looking for your tensor cores, you're looking for shared memory bandwidth, and you're looking for good L2 cache. You want the 4x PCI lanes or higher. You want no risers. You can have PCI or 16x extenders, which can help you with cooling and space and everything like that. So we're gonna have to figure out some kind of custom racks for these, I suppose, or different kind of open safe curvers. Anyways, guys, that was the video. I hope you enjoyed it. I hope it helps you figure out what's best for you, what's going to help you. The link for the article is going to be in the description down below. If you haven't, hit the like, hit the subscribe, share this video out, and just leave a comment. Let me know what GPU you're getting, or if you're trying to decide or figure out some information on what equipment to get. Thanks a lot, guys. See you later.